All right, good morning. So we're going to take a look at lesson 20, and we're going to start out with the first problem. As of September 2011, Florence Griffin Joyner, oh, I've been saying the wrong name, held the world record for the 100-meter dash. She set the record in 1998 with a time of 10.49 seconds. Which of the following calculations could be used to convert this speed into miles per hour? All right, so first things first. Whenever we're talking about speed, in miles per hour, the per should trigger bad memories of ratios. So we're talking about, in this case, she's doing 100 meters in 10.49 seconds. So anytime we're talking speed, we're talking a distance over time. And usually it's distance per unit time. So we would divide 100 by 10.49, but we're going to leave it there for right now. So if we look, the only one that sets up distance over time is B. And let's take a look at what it's doing. It's giving us a couple of conversion factors that we're going to need later. So first things first, we have 3.28 feet per meter. And anytime we start converting, we want to make sure that our conversion factor, since meters is in the numerator here, meter needs to be in the denominator of the conversion factor so that when we multiply, the meter cancels out and we're left with feet per second. Same thing holds with our next conversion where we're converting to miles. Feet again is in the numerator, so in the conversion, feet's in the denominator. Multiply again, now feet cancel out and we're left with miles per second. Continue forward, now we're doing our time conversions. Going all the way back to the first one, seconds is in the denominator, so in the conversion, seconds is in the numerator. These cancel out, and we're left with miles per minute. And then we convert one last time, minutes per hour. So again, minutes in the denominator, so minute in the numerator for the conversion. They cancel out, and we are left with, hour here and mile here as our two units. And then all we have to do in our next problem, which it's asking us to figure out the speed, is simply to multiply across. So we're going to take our 100 meters, we're going to multiply by 60, we're going to multiply by 60. And then we're going to take our initial 10.49 here, our conversion to feet here, and we're going to multiply them together. And that's going to give us, again, a new ratio. So when you calculator, be careful, put this part into parentheses. So 100 times 60 times 60 is 360,000 over, sorry for the noise in your calculator. 10.49 times 5,280 gives us 5,538.7.2 miles hour. Now, of course, we just want to go ahead and divide. So 360 divided by 55,387.2. And that's not right. What did I do wrong? That's right. Pardon for the... Oh, I forgot a number. I forgot my 3.28. Sorry. So that's going to change this number. So if we go ahead and just multiply across 100 times 60 times 60 times 3.28, and then we divide that by 10.49 times 5280. There we go. We end up with 21.3 miles per hour. So she was fast. Now, in this initial thing, right here's Jackie Joyner or Florence Griffin Joyner's numbers. Everything else are the conversion factors from seconds, meters per second, to miles per hour. So all we have to do is when we go down here, we take Michael Johnson with his 400-meter dash and 43.18 seconds, is we're simply going to take his 400 meters over 43.18. So this is meters per second. And we're going to multiply this by our conversions of 60 times 60 times 3.28. Let's not forget him again, her again, it again. And we're going to divide this by 5280, number of feet in a mile. So we get 400 times 60 times 60 times 3.28, and then we're going to simply divide that by 43.18 times 5280, and we get 20.7 miles per hour. So once we've identified our conversion factors, we don't have to rebuild the entire process. We can just take the conversion factors and go, okay, I can multiply meters per second times these numbers, and it's going to get me miles per hour. So we don't need to reconstruct the entire conversion chart. Matter of fact, we could go ahead and just multiply 60 times 60 times 3.28 divided by 5280. And we end up with this giving us 2.236 as a reasonable, to the thousandth place. It keeps going, but that's reasonable. That we can use this number as our conversion factor going forward to convert from meters per second to miles per hour. All right, let's take a look at the next one. Tony Kanaan set the record for the Indianapolis 500 in the time of 2 hours, 40 minutes, 3.4181 seconds. Find his average speed miles per hour. Same thing again, conversions. But it's a little simpler. All we need to do, we're already in miles per hour. We're already miles here. We have hours here. We have minutes, and we have seconds. So it's not a simple matter. We cannot divide 500 by 2 hours, 40 minutes, 3.4181 seconds. What we need to do is convert. And we need to either convert immediately to hours or to seconds. There's no reason to convert to minutes as the middle child. So if we convert to minute or to seconds, then we have 2 hours, which is 120 minutes. We add our 40 minutes. So now we have 160 minutes. We convert that to seconds by multiplying by 60, and we get 9,600 seconds. And now we add our 3.4181 and we get 9603.4181. Now our miles, again, miles per hour. So 500 miles per, in this case, seconds. And you can convert straight to hours instead of going to seconds the way I did. You would just divide your minutes by 60 and your seconds by 3,600 to convert them to hours. But this way we don't end up with really small decimals at the start. So this gives us, oops, I gave you going a little too fast. Let's ignore that last zero. This gives us 500 divided by 9603.4181. This gives us our miles per second. To get to hours, we need to convert 3,600 seconds over 1 hour. So we're just going to take, and we're going to multiply by 3,600. And when we do this, 500 times 3,600 divided by 9603.4181, we should end up with 187.433. Be careful because this says nearest thousandth, and so we need to go to 3 decimal places. So that's page 1. So right here, it's just asking us to simply set it up. So we have 44 feet per second as a fraction. So 44 feet, that's going to be our numerator. 44 feet, that's right, it's right over here, 44 feet per second, so 1 second, 1 second, 44 feet per second. Simple enough. Pause. Keep going. Okay, here we have a whole bunch of conversions. And we could set up the entire daisy chain of conversion factors, or we could remember what I did with Michael Johnson, and I said we have a conversion factor of 2.236. To convert meters per second to miles per hour. So we're going to take our horsefly and we're simply going to go 40.3 times 2.236 gives us a very fast horsefly at 90.1 miles per hour. And then we just keep doing this for each one. So our Skeeter, 0.5 times 2.236. Luckily, Skeeters do not fly that fast, so we can get away from them. And you can keep doing these for the rest of the charts. Don't worry about that. It's pretty straightforward. It's fractions. They're colored in on yours. So, multi-step problems. Cost of driving. 2010 Prius gets 48 miles per gallon. So that's telling us miles in the numerator, gallons in the denominator. Tank holds 11.9 gallons of fuel. Typically, low warning light comes on, approximately 2 gallons of fuel remaining. Which of the following correctly calculates the distance that can be traveled between the time the fuel light comes on and the car runs out? So when the fuel light comes on, we know we have 2 gallons left. So immediately, we're going to eliminate C because C is talking about the full range of full tank of gas. Remember, when we talk about miles per gallon, we have miles over gallon. So anything that's going to get us a distance is going to get rid of the gallon. So it has to, the conversion factor has to have the gallon in the numerator. So it's miles times gallons divided by gallons, and the gallons cancel out, giving you just the miles. So if we look over here we have 1/2 gallons times 48 miles per gallon gives us 24 miles. But if we look and we do our fraction multiplication, we have gallons times gallons. So this is actually 24 miles gallons squared, which makes 0 sense. So A is out of the picture. So if we look at D has the same problem because we have gallons times gallons with miles in the numerator. So this would actually be gallons squared per mile. Again, trash. And then if we look at B, we have gallons in the numerator, we have gallons in the denominator, so they cancel out. So we have 2 gallons times 48 miles gives us 96 miles. So B. Which leads us to the next one. So we have 13.5 gallons times its fuel economy of 45 miles per gallon. Gallons cancel out, and we have 45 times 13.5, 607.5. Okay. Number 20. The city of New York has a rate of 7.64 per 100 cubic feet of water. Cubic foot of water is 7.48 gallons. Standard wash machine uses approximately 50 gallons per load. Household washes 1 load of laundry per day. So if we want to build all our fractions, all our ratios, we could go $7.64 over 100 cubic feet. We have 1 cubic foot is 7.48 gallons. We have 50 gallons per load, and we have 1 load per day. So we're doing a lot of ratios, even though you don't realize it, and you probably don't even need to write these down. So it says, which of the following is true? Select all that apply. So be careful when something like this comes up and select all that apply. So our first question, average household uses 18,250 gallons of water per laundry per year. Simple enough. We know that a load of laundry is 50 gallons per load. We know they do 1 load per day. So 1 load per day. This allows us to cancel the loads out, and we have 50 gallons per day times 365 days in a year. So 50 times 365, you do indeed get 18,250 gallons per year. So A is true. Now, if we look, B, C, and D are all annual cost per household. So we just need to figure out the annual cost per household, and it'll tell us which one of these 3 is true. So we have our gallons already. We have gallons per year. And we need to convert this to dollars. So we have 18,250 gallons per year. We're going to change this because our price is in cubic feet. We're going to change this to cubic feet. So we're going to go, gallons is in the numerator, so gallons needs to be in the denominator. So 1 foot cubed per 7.48 gallons. And now we need to convert to cash, because now we have cubic feet per year. So we're going to multiply by our price of $7.64 per 100 feet cubed. And if we multiply all this together, 1A250 times 7.64 divided by 7.48 times 100, and we get $186.40 per year. B. Be careful, again, with these in parentheses when we're doing our conversions if we're setting it up, or you can do fraction mode on the calculator. Either way it works. Just be careful to ensure that you don't accidentally multiply by 100 instead of dividing by 100. Okay. I think the rest of these are pretty straightforward based on what we already did. Straightforward based on what we already did. And these are just applications. More problems. More problems, and that's it. So the rest of them should be pretty straightforward based on what we've gone over so far. So hopefully that will